Morning. Now in this lecture I am going to explain the flash distillation. In the previous classes we have discussed about the various methods of distillation. We know that one of the method is flash distillation. How the flash distillation works. It is represented in a brief diagram where F is the feed mousse having the concentration of XF that is enters to a heater where it is heated to a prescribed temperature, predetermined temperature. Then it is sent to the pressure reducer. Afterwards it goes to the flash separator, where the component feed is separated into two fractions. One is the distillate and another one is the residue. The more volatile component fractions are represented as XF, XD and XW. The quantities of the distillate represented as D and the residue is W. You can note that XW is equal to YD because it is in the vapor phase. To develop the operating line equations, we have to write the metal balance equations. So first one is the overall metal balance equation, that is total input is equal to total outputs. So that is F is equal to D plus W. Now I am going to draw the metal balance for the component, that is more volatile component. That is F into XF is equal to D into XD plus W into XW. Dividing the F on both sides and substituting the W is equal to F minus D, we get the equation as XF is equal to D by F into YD plus F minus D into F into XW. Now we are defining a fraction of material evaporated, that is equal to D by F, and substituting the D by F in the above equation and simplifying the equation, we are going to get YD is equal to minus of 1 minus F by F into XW into XF by F. For generalized purpose, we are removing the subscripts. Then the operating line equation becomes Y is equal to minus of 1 minus F by F into X plus XF by F. To draw the operating line equations, we have to know the point and the slope of the equation. So from this equation, it is observed that the slope of the operating line equation is minus of 1 minus F by F, and intercept is XF by F. So to identify the point, because we have another line called as diagonal line where F is equal to Y. These lines, that is operating line and the diagonal line, will meet at a particular point. To find out the position of the meeting point, I am putting the Y is equal to X in the above equation, and it is observed that X is equal to XF. Similarly, if you put the X is equal to Y, then Y value is equal to XF. That indicates that the coordinates, the point on the intersection is XF. With the help of the slope of minus 1 minus F by F, we have to draw the operating line equation. Now I am explaining how to draw the equilibrium curve and operating line. So from the data of the equilibrium may be directly available or may be available in terms of alpha. You can calculate the X and Y values, and once you know the X and Y values, you can draw the equilibrium curve. Once you have drawn the equilibrium curve, now identify the position of XF, that is at the point of XF, draw the vertical line, it will cut the diagonal line at a particular point. That point becomes the feed position of the material. Now from this feed position of the material, with the help of the slope of -1 minus F by F, draw the operating line. It will cut the equilibrium line at a particular position. The position gives the corresponding values of YD or XD and the corresponding values of XW. Like this, we will calculate the composition of the more volatile component in the vapor phase and the residue phase. Now I am going to explain how to calculate the quantities of the residues as well as the distillate. So I am taking the overall metal balance equation and I am taking the component metal balance equation. So the component metal balance equation can be written as F into XF by substituting the D is equal to F minus W into XD plus W into XW. We know the F value, XF value, XD value, XW value from the graph as well as the data of the statement of the problem. You can calculate the amount of residue obtained. Once you have got the W value, you can substitute in the overall metal balance equation or component metal balance equation and you can calculate the W value. So this is regarding the distillation, flash distillation. Now the lecture is end. This is the end of the lecture. You can have the detailed interaction in the next classes or in the class. Thank you.